Good morning, good afternoon, good night. Let's go ahead and jump into 3-4, our last section of chapter 3, in the last section before your test. All right, so make sure you have your notes out, obviously, and let's get rolling. So we're going to first talk about what the difference is between convex and concave sets, okay? And in this case, we're talking about sets of points, okay? All right, so a convex set is a set that for every 2 points in the set, the segment that connects them is entirely within the set, okay? So it doesn't leave the set. So and it's concave if the segment that connects any 2 points leaves the set, okay? So let's look here. If we're talking about this polygon and its interior, this region, right? Would this be convex or concave? So in order for it to be convex, every single possible combination of 2 points, the segment that connects them has to stay within the set. So is that going to happen here? What if I picked a point right here and right here? Is the line segment that connects them, does that stay within the set? Absolutely not. What if I pick, this point and this point? No, obviously not, right? It leaves it when it goes outside there. So this, we would say, is concave. What about this circle? Can you pick 2 points that the segment leaves the set? Hopefully you said no, because it's convex. Okay, no matter what you do, if I pick for this circular region, if I pick a point here and any other point, even one that's right here, I mean, technically it may not look like it, but technically it stays within the set. Okay. All right, what about this one? What do you think? Hopefully you said concave. Yeah, obviously we could put a point here and a point here, right? And it's gonna leave the region. Okay, so that's convex versus concave sets. So what about a plane? We're just talking about a plane. Is it concave or convex? Think about it. If I took any 2 points on my plane here, won't the line segment that connects them stay within the paper or stay within the plane? So it's convex, big time. All right. Let's talk a little bit about half planes, okay? So if I have my plane here, and remember, this obviously extends forever in all these directions, right? But if I have a line here, it's going to cut a plane into 2 half planes, okay? Now, let me ask you this. How many lines are contained within this plane? Hopefully you said an infinite, right? I could have line there, line there, line there, line there. If this plane extends out, I could have one here, and so forth. So every single line cuts a plane into 2 half planes. So now I'm not saying that every single line cuts the exact 2 half planes. No, if I'm using line L here, 1 half plane, which we labeled H1, would be this way, right? And H2, the second half plane, would be this way. But I could put another line in. Let's use a different color. I could put a line in right here, right? And then all of a sudden, it's this line's still in the same plane. Here would be a half plane, and over here would be a half plane. Okay, still creating 2 half planes, just different half planes. Okay. Here we have line L. Let me go ahead and get rid of that real quick. Line L is what we call the edge of each half plane, okay? And a half plane does not contain its edge. So if I ask you, is line L in half plane 1? The answer would be no. If I said, is line L in half plane 2? The answer would be still no. Okay, great. All right. The segment connecting any 2 points in the same blank never intersects the edge. Hopefully you said half plane, okay? Where's an example of that? Right here, P and Q, right? They're both in half plane 1. Does the segment that connects them intersect the edge? No. Segment, right? Okay. T and U, opposite half planes. So their segment would, right? Okay. Oh, I have that down here. Okay. And different half planes will intersect the edge. Okay. Okay. So the plane separation postulate just basically recaps that information. It basically says a line lying on a plane forms 2 sets called half planes. Okay. The half planes are convex. Okay. Obviously. And do half planes contain their edge? No. Okay. If 2 points are in different half planes, then the blank that connects them intersects the blank. What would it be? We've already gone through this, really. The segment that connects them intersects the edge, right? How many half planes are possible in a plane? Careful. Careful. Whoop, whoop, what did I do there? Hopefully, I don't know why that went like away like that. That was weird. How many half planes are possible in a plane? It's kind of a trick question, right? Think about it. If I'm just talking about with one line, it's going to only create 2 half planes. That's the amount possible. But since there's an infinite number of lines, there's an infinite number of ways to create half planes. So it'd be infinite. And I'm not sure why I don't have that down here as an answer. That's interesting. Maybe it was supposed to be underneath that thing and I erased it. So infinite. Okay. If a line cuts a half plane in half, what cuts space in half? We already talked about this in our last lesson, I believe. What was it? What was it? Oh yeah, a plane, right? If I pull a plane out here, back here is a half space, and up here is a half space. And remember, this plane extends forever, right? So the 2 half spaces, right? So how many possible half spaces? Oh wait, sorry, a face, excuse me, a face, think of it this way. A face for a half space is like a line or an edge, excuse me, line, edge, kind of similar, for a plane, right, or a half plane. Okay, so a face is a plane that separates space. This is that. Do you think this is in either half space? Absolutely not. Same as up there. How many possible half spaces are there? Well, if there's an infinite number of planes, there's going to be an infinite number of half spaces. Okay, and that's basically what we just went through is basically the space separation postulate, okay? It's basically the same as the plane separation postulate, but in 3 dimensions, okay? A plane is also known as a face, is not in either half space. Half spaces are convex, right? Because any 2 points that you join in a half space, the same half space, are not going to leave that half space. Ah, here he is with the coffee. Thank you, young sir. Much appreciated. Cheers. And half spaces are convex, we just said that, and the segment joining points in different half spaces are going to what? They're going to intersect the face, yes. All right, pull out your book to page 65. And let's look at problems 1 and 2 and go through some of those. Okay, so these are yes or no questions, okay? A, is a line a convex set? Remember, to be a convex set, a segment containing every single possible 2 points has to stay within that set. So what do you think about a line? Answer would be yes, right? Because any 2 points that are on that line, if you connect them, the segment's going to be on that line. So it stays within it, so it's convex. B, is a set consisting of only 2 points convex? What do you think? Answer is no. How could it be, right? How can you have a segment joining them? Wouldn't the segment have to go through another point? So the answer would be no. Doesn't meet that definition. C, is a circle a convex set? Careful. Did they say circular region? Did they say interior of a circle? No, they didn't. They said circle. So is it? The answer would be no, it's not convex. It's concave, right? Because we're talking about only the points in the circle. Obviously, if you have a circle and you pick any 2 points on that circle, there's one right here, and I'll pick one right here randomly, and I connect that, that line segment is not on the circle anymore, is it? Okay, circular region, concave or convex, already went all through that, it would be convex. What about the interior of a circle? Think about it. Any 2 points are on the interior, right? The segment would stay inside, okay? What about the exterior of a circle, meaning just everything around the circle? What do you think? Remember, all you need is one counterexample to show that it doesn't work. And obviously, if I picked a point here and a point here, and I'm talking about the exterior of the circle, I left the exterior when I went in here or touched the circle. So the answer to there, anyway, they asked for a circle, was no, it would be not be convex, it's concave. Okay, is the region enclosed by a circle a convex set? Yes, we won't do that. That's called the interior of the circle. Does a point separate a plane? No. Does a point separate space? No. Does a point separate a line? Yes, it does. Think about it, right? You have a point separates a line into what we call 2 rays. Okay. All right, question number 2. Again, yes or no? A, if a single point is removed from a line, do the remaining points form a convex set? So, this is so much fun to do. We're going to draw a line, right? Oops, pretend it's straight, right? You can assume that because we're doing Euclidean geometry. Okay, and then I take an eraser, and let's get a small, and I take out a point right there. They're asking, is this now a convex set? And the answer is, what do you think? Hopefully you said no, because remember, all you need is one counterexample to show it's not true. So what if I picked this point right here and this point right here? Does the segment that connects them leave the set? Yeah, it sure does, right there, right? It leaves it because we took that point out. So that would not be convex, it would be concave. Is a sphere a convex set? No, because we're just talking about the points on the sphere. The connection would go into the interior, so the answer wouldn't be no. Is the space enclosed by a sphere a convex set? In other words, the interior of a sphere? Yes. Okay. D, does a ray separate a plane? Does a ray separate a plane? The answer would be no, right? If we had something like this and we just have a ray going this way, remember, a ray has one endpoint and then it continues on. It's like half a line, right? No, it doesn't separate this part of the plane into 2 parts. So the answer would be no. Does a ray separate, or does a line separate a plane? Yeah, it's called an edge, right? And what about a segment? No, similar here. Like if I just had a segment here, you know, it doesn't really separate the plane down here or up here. Okay. Can 2 lines in a plane separate the plane into 2 regions? Think about it. 2 lines. Can 2 lines in a plane separate the plane into 2 regions? 2 lines. No, no way. Could it separate could 2 lines separate into 3 regions? Try it. So literally, like could you have a plane? Can you draw 2 lines that separates it into 3 regions? Sure, right? If you had one line here and another line here, right? If they were parallel, right? And by the way, if you put a little kind of V or arrow mark inside, that means that those are parallel. They have the same number of those, right? 1 region, 2 regions, 3 regions. Do you think you could do 4? Yeah, if you had 2 intersecting lines, right? It would kind of create 4 regions. And what about 5 regions? just using 2 lines. Is that possible? If you can figure it out, let me know, because I haven't been able to. So I think the answer is no. Okay, well, that covers it. Remember, this is not necessarily your homework, although it might be. Go by what's on Schoology. And that covers it for our first unit in terms of the material. So from here on out, it's just practicing this, and then we'll take a little assessment. You can show me everything you learned, which would be awesome. All right, well, that does it for that. Congratulations on finishing the material for the first unit. All right, I'll see you soon. Bye.